So the outline of this presentation is going to a small introduction of background, then Radiomics Workflow, extracting Radiomics from medical images, then I will show example, and at the end the conclusion. So let's start by medical images and biomarkers. As you know, imaging techniques nowadays are increasingly being used to perform an invasive assessment for tumor biology in clinical practice. So these images contains detailed information about structural or diagnosis related changes. So early diagnosis saves lives, and without diagnosis, there is no treatment or there is no cure. So biomarkers that can be extracted from medical images can be used to diagnose diseases, and these biomarkers can be referred to image features. So what are the biomarkers, or how biomarkers can be extracted for diagnosing cancer diseases? It can be extracted by various techniques. For example, it can be through morphology and clinical data, the analysis of this data. And also it can be diagnosed through dynamic evaluation of the images. For example, CT scan, MRI, and PET scan. And also they can use radiomics. So what is radiomics? Radiomics, it means extracting features from these medical images using many techniques such as machine learning or deep learning. So why exactly we are focusing on the radiomics? Because it is a non-invasive assessment methods. So what are these radiomics? So these radiomics, it means characterization of the content of region of interest, which is, for example, cancer in the image. It can extract more features such as the area of the shape or the volume of the cancer and other features that can be extracted using mathematical equations. So radiomics has shown considerable growth in cancer research nowadays, and it can be used for analysis, used for classification of benign and malignant tissue. Also, it can add information about tumor aggressiveness, and it can also be used to predict responsiveness to chemotherapy. So why exactly we want why radiomics? Because it is the manual assessment of treatment are not accurate, and it is limited measure size of tumor only. Regarding the radiomics, it extracts many features from the image, and it is really a promised approach for predicting the cancers or for early diagnosis. So what is the radiomic workflow? It starts by acquiring CT images or MRI or PET scan images, and also then the segmentation method, which means delineating the region of interest, which means the cancer area. Then after delineating the cancer area, we can extract the features from this cancer area that can be used to protect for predicting the chemotherapy or for predicting the diagnosis. So let's see each of these phases. For example, the image acquisitions can be acquired from different modalities such as CT scan, MRI, PET scan, and there are many CT parameters, for example, can be used for acquiring the image, such as defining the scan type, detector rows, tube voltage, tube current, slice thickness, and contrast. Then the image segmentation. Image segmentation, as I stated before, it means delineating of the region of interest, which means the cancer area, as you see in this image. And the image segmentation might be done manually by delineating this by radiologists who are working in the field, by using some software that can allow them to delineate this manually, or it can be fully automated using deep learning algorithms such as unit architecture, for example. And there are also many software that can assist for image segmentation, such as 3D Slicer, LifeX, and many others. So how the features can be extracted from the segmented region, which means the radiomics, how can be extracted? There are many extraction tools available in the internet. The most popular one nowadays called Radiomics. It is based on Python package, and it can work as followed by the segmented region will be the input to this package, and after applying the package, we can extract the features in Excel file that can be used later on for analysis. Then we can use feature selection to, for example, remove the redundant data or non-relevant features before analyzing this data using deep learning algorithms. And here the general artificial intelligence approaches for the radiomics. After acquiring the image and extracting the features from the image, it will come the data pre-processing, which means removing or preparing the data to be for the analysis. Then we can input this data into machine learning models or deep learning models for prediction or classification. Here is an example. For example, after extracting the feature using this Radiomics tool, we will get data in Excel file like this. It is a numeric data. And then we can use this data for analysis. For example, I have here the sample, which I analyze it. This is the radiomics features, which are extracted to protect the deletion of gene, for example, with the brain. After using the deep learning algorithm, this is the steps of using the deep learning or machine learning algorithm. It starts by data pre-processing, by handling the null values, applying label encoder for categorical data, and then applying data rescaling or normalization, then data splitting into training and testing set, then building model like logistic regression support, vector machine, random forest classifier, deep learning model, then feature selection, which uses to extract the most relevant features that can be used for prediction. Then I applied cross-validation and grid search CV just to improve the performance and find the best hyperparameters for the model. And this is the results after applying the deep learning model on analyzing radiomics. I got accuracy of 80% using simple deep learning, and by increasing the number of layers of deep learning model, I got 88%. So this suggests the model, the deep learning model is promising for analyzing the radiomics. And this is my conclusion. Medical imaging contains a great amount of data in the form of gray level patterns that can be extracted by radiomics. And radiomics plays a vital role in the rapid response assessment and prediction or classification in cancer research. AI in combination with radiomics appear particularly promising, especially for identification and segmentation of small lesions or small areas of cancers. So deep learning shows better results in analyzing radiomics. And this is my references.